Hi, welcome to my channel. This video is regarding Linux booting process. Have you wondered what happens in the background when you power on your computer? When you click on the power on button of your Linux system, it initiates a sequence of processes. The first process is boot process, which starts from powering up your machine to initialization of your kernel to setting up of system D, and it is followed by the startup process, which continues from the boot process and makes your Linux system operational. The first step in boot process is the BIOS post. BIOS post process is not a Linux specific process, but it is common for all OS, which happens with the power on of your machine. BIOS is actually a firmware on your motherboard which runs the post or the power on self test. Post is actually multiple tests on all your hardware systems to confirm that your hardware is working fine. Only then the booting process will continue. So once the post is successful, it loads the bootloader. Once the BIOS post has successfully completed, it will load the hard disk, CD-ROM and RAM. Then it will search for the MBR or the master boot record. The BIOS then passes the control to the MBR. MBR is the first sector of your hard disk. It is a 512-byte storage wherein the bootloader is present. The MBR would load the bootloader into the RAM. Bootloader is basically a code specific to your OS. For your Linux, you have LILO, grub, grub2, etc. as bootloaders. Presently, the most commonly used bootloader is grub2. Grub stands for Grand Unified Bootloader. Once the grub is loaded into the RAM, it searches for the kernel. The purpose of grub is to find the kernel image present in the /boot directory and to load it. Kernel is basically an interface between your users and the underlying hardware. So once the grub2 bootloader locates the kernel in the /boot directory, which also contains RAM disk image informations and the hard drive mapping, the kernel, which is in compressed format, will uncompress itself and would call the systemd. So this marks the end of our boot process. So currently we have the Linux kernel and the systemd process running on our Linux system, but the users won't be able to access. To make the system operational, we'll have to do the startup process. So the startup process starts with the systemd process, which is the mother of all processes. Systemd is similar to the old init process, but have some extra extensive processes. So first, systemd mounts the file systems as mentioned in the etc fstab configuration. It also includes the swap files and partitions. Next, it accesses the configuration defaults.target, which determines that which state or target should it boot the host. The systemd though runs its processes in parallel, but still it has a couple of checkpoints. The first checkpoint is sysinit.target. It involves the mounting of file systems, setting up swap files, initiating low-level services, etc. Then the next checkpoint is basic.target, which includes setting up paths to various executable directories, communication sockets, and timers, etc. Once these targets have been set up, next the user level targets are started, like emergency target for single user mode, multi-user target for text mode login on console, and graphical target for GUI. So once this stage is completed, the users would be able to access the OS as per the started target. So to summarize, how the Linux booting works is, first the BIOS, which is a firmware on the motherboard, runs the power on self-test. After successful testing of the hardwares, it searches for the MBR or the master boot record, which is the first sector on the hard disk. MBR then points to the bootloader, the latest being grub2 for Linux. And the bootloader will load the kernel. The kernel will run the systemd process. The systemd will mount the file systems using the etc fstab configuration and also load the default.target configurations, which will initiate the user interface. So hope this information was helpful to you. Thank you for watching my video.